I'm going to find, hello. I'm going to stop my screen for a second and see who we have in here. Hi, Ben. See Ariel. See Afua is on. See Shane. I see Kaylin. Hi. Landon, Columbus. Awesome. So what I'm going to do real quick is I'm going to send you all the link for the Padlet. What I would like you to do is go ahead and read a couple of your classmates' like wonderful achievements and just kind of put a comment or like a little love on their wonderful achievements, because I really loved reading them and I hope you guys would too. So let me get that link. Copy it and put it in the chat. Can you all see the chat? So go ahead and take a couple minutes and just write a little bit of a comment for your friends. Okay, while I get myself set up over here. All right, I'm pasting the Padlet link for anybody that did not see it the first time. Okay, for people coming in, I want you to take a couple minutes and go on the Padlet and comment on one of your classmates' wonderful achievements that they made from start of quarantine till now. We'll give it about 30 more seconds. Hi, Katie. I just saw Katie. Where did she go? Oh, there she is. Hi. Ooh, I like the, is your hair red? Oh, it's wonderful. I love it. Absolutely wonderful. All right. So if everybody can come back here so we can kind of talk about what robotics is going to look like for this 9 weeks. So I hope that you all are well. I hope that the first week of school hasn't been too stressful on you. So I'll be sending out some links just to kind of see like how robotics will fit into your life in your core classes. Honestly, you're going to have about one Zoom a week with me, basically, a check-in day, and then everything else is on your own. Does that sound pretty doable for right now? Yeah? All right, so I'm going to share my screen. I'm going to show you the syllabus real quick. Find it. There it is. All right. So this is only a 9-week class. So we're going to do as much as we can in the 9 weeks that we have. In the ideal scenario, we would have been working with the Lego Mindstorms kits from day one. But since we are working with a lot of online platforms, you're going to be doing the majority on like simulations online. So if you are familiar with those kind of outlets, that would be fantastic tool to have. So to start off with, here's all my information. You don't have to copy this down. Obviously, you all know how to get in touch with me. But our Zoom meetings are going to be every Tuesday at this time at 10:30. So without fail, I will have a Zoom meeting every Tuesday. Thursdays will be from 10:30 to 11:30. If you're having any trouble with any of the platforms, with any of your builds that you're going to do, I will be available for you during that time. Okay? So basically, the course is going to give you a working knowledge of how robotics came about and how robots actually work and what actually is considered a robot. You're going to be doing programming activities, basically project-based context for real world problems. So everything that you have, that we've talked about in STEM with like real world, real people-based scenarios, we're going to kind of apply that to robotics as well. So here's just a little quote. Can you read that for like 30 seconds? I'm not going to read it to you. So have you seen those YouTube videos or any of those videos with like the cats on like the what is it, the Roomba, and they're like riding around? So like we're talking about doing such a very basic trivial task to something that is, potentially life-saving. That is a huge range that robots can be involved in. So I want you to know that you're kind of just scratching the surface in this 9-week course with what the abilities of robotics can take you. So why? So a lot of our future careers are going to involve problem solving and training. A lot of artificial intelligence and robotics are going to be used to enrich society, especially now that like face-to-face contact and we're learning more about like how to not spread diseases amongst ourselves. We're going to talk a little bit about how robotics can play a part in that. NASA, if you've been following all the recent rocket launches and all the different space exploration things, NASA has increased its demand for robotics engineers, people who are going to remote operate like rovers and robotics, like the different robotic arms from space and all the different kind of things that you can do for space exploration. So those can be career opening skills that you can have even starting now. Okay, so we're getting to get into what kind of project types we're going to do. So we're going to do 3 different things for this 9 weeks. You're going to do online simulations, like I mentioned before. So those assignments are going to be at your own pace. I'm going to give you tutorials and videos online to support you, as well as the simulations themselves will have tutorials. You will be using coding. Obviously, all the coding skills that you have built up through the years will definitely come in handy. There are going to be a lot of block coding like you've seen before, so it shouldn't be anything completely new. So just so you're aware of that. We're going to do a couple team challenges throughout the actual 9 weeks where you'll work with a simulation on like how a robot will get through this different scenario, or what kind of sensor or what kind of motor or what kind, like different things that you're going to work together with a couple of different people to solve a real problem. And then the third one is at home building. And you see how I put a couple asterisks there? So the plan is to get you a Lego kit at home, okay? Is to send home for about 2 weeks a EV3 kit so that you can actually build and test out those different kits. Okay. So the stipulation is that if things don't calm down virus wise, we might have to put a kibosh on that, meaning that I might stop that just for the safety of you and others. Because what I plan on doing is sending out for 2 weeks one set of people and then clean that kit and then send that off to another set of people. Make sense? Okay. So these could be completed at your own pace. You must complete 3 tasks that I'll give you out of a whole set of different tasks. While people are doing the at-home building, the other half of the class will be doing online simulations. So once we get close to that, like in the next 3 weeks, once we go over like the basics of robotics, then I'll tell you how that's actually going to work out. Okay, everybody with me so far? Cool. All right. I can only see a couple of you on my little screen over there. That's okay. So how will I be graded? You're going to be graded with single point rubrics. So if you've known my classes in the past, I've given like multiple sections for different rubrics. So basically you'll have like a goal of, was I able to build and code a robot to do a specific task? 0 being no, 4 being yes, you went above and beyond and you created something even better than what I was given you to do. Okay, so I will be just doing a single point rubric, and I'll share what a single point rubric looks like next week for our first little intro project. All right. And then group projects, you'll have a peer review, peer feedback, Zoom participation. You know, you being here today is obviously giving you a head up on those participation points. So I asked you on Monday to fill out the Google form to make sure that your computer has a USB port, Bluetooth capability, you have Google Drive, access to Google Drive, and access to internet Wi-Fi. In the next couple days, I'm going to be sending out like a actual file to try and download on your computer, which you're going to need when you get those kits at home. So what I would like you to do is try and download those things, and we're going to try and see if you are able to download it at school or at home. And if not, then we'll have to get you some permissions to do so, to download those files. But basically what you need is a USB port, Bluetooth capability, Google Drive, and access to internet. Okay. All right, so I just wanted to kind of share with you a little bit. 2,439,543 is the number of industrial robots in the world. That is absolutely a staggering number, and that number keeps growing. That number is projected to double, not just in the next 5 years, in the next 2 years. That number is projected to double. So a lot of what you're learning, the basics of what you're learning now, is going to drive your everyday life in the coming years. So once you enter high school, that number will double. That's insane. All right, so going back to what our weekly breakdown is going to be. So week 1 is obviously this week. So we're going to do a little boat challenge. We're going to do a team building challenge on Thursday. We're doing our Zoom meeting today. Next week is what is a robot? We're going to look at the parts of a robot. Week 3 is looking at the actual Lego EV3 system and taking a look at what the different parts are. Number 4 is how they all function and work together, talking about the circuitry, the gear systems, how things move and work, how sensors work, all those different things. And then weeks 5 and 6 and 7, 8 are going to be the alternating. Half the class gets a kit to take home because we have 9 full kits at the school. So only about 8 or 9 people at a time will get one. So half the people will get the at-home building kit, and then half of the class will be doing online simulations. Okay. And then week 9, we're going to do a final assessment, end of unit Google Slides presentation where you'll provide. I haven't quite figured out what your final presentation is going to be, but you're going to create a Google Slides to present to me on what you've learned. Okay. All right. Before we move on, does anybody have any questions? You can unmute yourself if you want to, or you can type it in the chat box. No, nothing. Anybody? Cool. All right. So what I'm going to do right now is I'm going to play a quick little video. It's about 6 minutes long. I might cut that off halfway, but we're going to do a quick discussion because this question right here: how can autonomous robots that can perform behaviors and tasks without outside help, so like if they can move on their own, be used to support our society during this time of a pandemic? I want you to think about that while you watch this video. Real quick. Can you see this video? Can you give me a thumbs up if you can see the video? Thumbs up? Okay, cool. Can you hear the video? Can I have a thumbs up if you can hear the video? Let me play it real quick. Yeah, cool. All right, so we're gonna watch it for about 6 minutes.
That's Spot Mini. He'll be back in a little while. I love building robots. And my long-term goal is to build robots that can do what people and animals do. And there's 3 things in particular that we're interested in. One is balance and dynamic mobility. The second one is mobile manipulation. And the third one is mobile perception. So dynamic mobility and balance. I'm going to do a demo for you. I'm standing here balancing. I can see you're not very impressed. Okay, how about now? How about now? Those simple capabilities mean that people can go almost anywhere on Earth on any kind of terrain. And we want to capture that for robots. What about manipulation? I'm holding this clicker in my hand. I'm not even looking at it, and I can manipulate it without any problem. But even more important, I can move my body while I hold the manipulator, the clicker, and stabilize and coordinate my body, and I can even walk around. And that means that I can move around in the world and expand the range of my arms and my hands and really be able to handle almost anything. So that's mobile manipulation. And all of you can do this. And third is perception. You know, I'm looking out of the room with over 1,000 people in it, and my amazing visual system can see every one of you. You're all stable in space, even when I move my head, even when I move around. That kind of mobile perception is really important for robots that are going to move and act out in the world. So I'm going to give you a little status report on where we are in developing robots toward these ends. This is, the first 3 robots are all dynamically stabilized robots. This one goes back over a little over 10 years ago, Big Dog, and it's got a gyroscope that helps stabilize it. It's got sensors and a control computer. Here's a cheetah robot that's running with a galloping gait where it recycles its energy, it bounces on the ground, and it's computing all the time in order to keep itself stabilized and propelled. And here's a bigger robot that's got such good locomotion using its legs that it can go in deep snow. This is about 10 inches deep, and it doesn't really have any trouble. This is Spot, a new generation of robot, just the slightly older than the one that came out on stage. And we've been asking the question, you know, you've all heard about drone delivery. Can we deliver packages to your houses with drones? Well, what about plain old legged robot delivery? So we've been taking our robot to our employees' homes to see whether we could get in the various access ways. And believe me, in the Boston area, there's every manner of stairway, twists and turns. And so it's a real challenge, but we're doing very well, about 70% of the ways. And here's mobile manipulation, where we've put an arm on the robot, and it's finding its way through the door. Now, one of the important things about making autonomous robots is to make them not do just exactly what you say, but make them deal with the uncertainty of what happens in the real world. So we have Steve there, one of the engineers, is giving the robot a hard time. And the fact that the programming still tolerates all that disturbance, it does what it's supposed to. Here's another example where Eric is tugging on the robot as it goes up the stairs. And believe me, getting it to do what it's supposed to do in those circumstances is a real challenge, but the result is something that's going to generalize and make robots much more autonomous than they would be otherwise. This is Atlas, a humanoid robot. It's a 3rd generation humanoid that we've been building. I'll tell you a little bit about the hardware design later. And we've been saying, how close to human levels of performance and speed could we get in an ordinary task like moving boxes around on a conveyor? And you know, we're getting up to about 2/3 of the speed that a human operates on average. And this robot is using both hands, it's using its body, it's stepping. So it's really an example of dynamic stability, mobile manipulation, and mobile perception. Here, we actually have 2 Atlases. Now, everything doesn't go exactly the way it's supposed to. And here's our latest robot called Handle. Handle is interesting because it's sort of half like an animal, and it's half something else, with these leg-like things and wheels. It's got its arms on in kind of a funny way. But it really does some remarkable things. It can carry 400 pounds, 100 pounds. It's probably going to lift more than that, but so far we've done 100. It's got some pretty good rough terrain capability, even though it has wheels. And Handle loves to put on a show.
All right, I'm going to stop us there. I'm going to link the full video on Google Classroom, so if you guys want to watch it. But before we go, I just want you to take about 2 minutes. I'm going to send you into a breakout room, and I want you to take about 2 minutes and see how these autonomous robots, these robots that can behave and think on their own, how might they actually help us in this time of a pandemic where getting close to another person is not advisable at this time. So I'm going to send about 4 people per room, so you guys can unmute yourself and kind of chit chat about that for about 2 minutes, and then we'll all come back. Okay, I'm going to send you now. All right, it looks like everyone is back. Does anyone want to share something that their group had talked about? You can unmute yourself. Go ahead, Katie.
So my group talked about like how the robots could help during the pandemic and how like it would help with delivering packages a lot easier, and like because robots can't really get the coronavirus, and it would be a lot more efficient if they could like carry packages to other places. And that's what my group talked about.
That's awesome. Thanks.
Mhm.
Does anybody else want to share? Go ahead and unmute yourself if you feel like you want to. Okay. Well, that's going to conclude our day today. What's going to happen on Thursday? I am going to ask you that you actually do attend on Thursday. I'm going to send a reminder for a team building activity. It works so much better if we have more people. So on Thursday, 10:30, you'll get another Zoom notification. But I hope you all have a great day. It's wonderful seeing your faces, even if you didn't turn on your computer or your video. Thank you so much for sharing. And I hope you all have a great day. Email me any questions that you need. Bye all. See ya.